Hello everyone. In this video, we are going to discuss a special case of transportation problem known as degeneracy. As we have discussed that the initial feasible solution of a transportation problem should have m plus n minus 1 number of occupied cells, where m denotes the number of sources and n denotes the number of destinations. It means if a problem, suppose this one, it has 4 sources, that is m is equal to 4, and 5 destinations, it means n is equal to 5 minus 1. So there would be 8 occupied cells or 8 basic variables. But sometimes what happens that the number of occupied cells is smaller than n plus n minus 1. Like in this problem, there should be 8 occupied cells, but in reality there are 1, 2, 3, 4, 5, 6 and 7 occupied cells only. It means the condition of m plus n minus 1 is not satisfied in this particular problem. So if the condition is not satisfied, then we call it the case of degeneracy. It is a degenerate solution. Okay. So in this particular case, we have calculated the initial feasible solution with the help of least cost method, and this method generated an initial feasible solution with degeneracy. It means the number of cells, the number of occupied cells are less than n plus n minus 1. So what is the problem or difficulty with the case of degeneracy? You remember, after calculating initial feasible solution, we have to test the optimality of that feasible solution. Okay, and for that purpose we need to apply stepping stone method or modified distribution method. But both of these methods are inoperative in condition of degeneracy. They cannot be applied if the initial feasible solution is degenerated or the condition of m plus n minus 1 is violated. So in that case we cannot apply stepping stone method and modified distribution method. The reason is that if there are less than m plus n minus 1 number of occupied cells, then there is possibility that we would not be able to formulate the closed loop for all of the empty cells, and that means we would not be able to calculate the opportunity cost for every empty cell. So it would make the stepping stone method inoperative in this condition. Similarly, in case of modified distribution method, we won't be able to calculate the values for U and V indexes, or we won't be able to find the index values. So again we would not be able to calculate or apply the test the optimality of the problem. So to overcome this problem, we need to find a solution, and that solution is suggested in these steps. And what are those steps? Step 1, select the least value. So among the unoccupied cells, what we have to do, we need to select the unoccupied cell with minimum cost. Okay, remember, with minimum cost. So in this particular table, the cell with minimum cost is this one, S3D2, and another one is S2D1. S2D1. So basically there is a time between two minimum costs, or two cells with minimum cost. So at this stage we can select either of them. We can go with this one or this one. So step 2, now come to the second step, and second condition is that we need to check if there is any closed loop formation starting from the selected cell. Like if we have selected this one, then we have to test if there is a closed loop formation or not. So basic condition, what we have to test in this step is that the cell should be independent. And what is the meaning of independent? It means that there would be no closed loop formation from this cell. If it is the case, then only then we can move ahead. Now look at this cell S3D2. If you try to trace the closed loop, then we would find that there is no closed loop formation for this particular cell. Either we go from this side to this side, then we can come to downwards. If we move to this one, then we can't go to upward or downward. So there is no closed loop formation for this particular cell. So second condition is satisfied, that this cell is independent, that there is no closed loop formation starting from this cell. Now what is the next step? It is allocate small amount that is close to 0. Now what we have to do? We have to allocate in this particular cell a small quantity of the product, and it is that much small that it is close to 0. It is close to 0 but not 0. Okay, remember that it is close to 0 but not 0. And generally we denote this quantity with a Greek letter E, and we call it epsilon. It is epsilon. So we allocate the quantity equal to what? Epsilon. Epsilon, the value of epsilon is close to 0 but not 0. If we look at some mathematical operations on this particular variable or this particular value, then suppose there's any amount, like it is 10. If we add e into 10, we are adding e into 10. E is that much small that it is not affecting 10. 10 plus e would be equal to 10. So this value is almost 0. If we want to reduce epsilon from 10, then in that case also it would be equal to 10, because it is not reducing 10 by any significant amount. And if you want to add epsilon into epsilon, then it would be equal to epsilon. If you want to reduce epsilon from epsilon, then it would be equal to 0. So there are some mathematical operations. From that we can understand the basic concept of epsilon. So this amount is large enough that we can consider the particular cell as an occupied cell, okay, but not large enough to affect the total cost of transportation. So what is the meaning of this? That by assigning this amount to this particular cell is not going to affect the total cost of transportation, okay, but this value is large enough that we can consider this cell as an occupied cell, okay. You must remember it while calculating such type of problems. So when you face a problem of degeneracy at the time of calculating initial feasible solution, or sometime at the time of calculating optimal solution of a problem, so you can face it at any stage, at time of calculating initial feasible solution, or at the time of calculating optimal solution of a transportation problem. So in that case, what we have to do, simply select the least value, select the empty cell with the least cost of transportation, then check if the selected cell is independent or not, and then after checking that, if that cell is independent, then assign a quantity equal to E or epsilon, so that we can consider this cell as an occupied cell, and the condition of m plus n minus 1 is satisfied. So from now on we can apply stepping stone method and modified distribution method to test the optimality of this transportation problem. Take another case. What if this cell is not optimal? This cell is not independent. Then what we have to do? This cell is not independent. What does it mean? It means we can trace a closed loop starting from this point. It is possible to trace a closed loop or formulate a closed loop starting from this particular point. Then what we have to do, we would reject this cell and would go in search for another cell with the next minimum cost. Okay, suppose we can go for 5, or if 5 is not there, then we can go for next minimum is 7 in unoccupied cells only. Okay, so it would be the procedure. And then the situation may arise that sometimes we have to assign 2 epsilons. We may fall short of the condition of n plus n minus 1 by a number of 2. We can have the occupied cells lesser than n plus n minus 1. Okay, so there can be a need that we have to assign 2 epsilons in unoccupied cells. So in this way, after allocating epsilon, we can apply any method, and we can proceed with in a similar manner as we have done in the earlier cases. So in next video we will discuss some another special cases of the transportation problems. Thank you.